Bismillah, assalamu alaikum wa rahmatullahi wa barakatuh. My name is Khalid Shumrani. I am a member of a static equipment team. Today, inshallah, I'm going to present to you and show you a simple illustration of ANSYS software. It is basically a mechanical finite element software which is used to simulate a model of several structures. It allows user to perform analysis on strength, temperature distribution, fluid flow, and many other aspects. As you can see, when you open the ANSYS software, you see this page, which is the workbench. And you've got here a toolbox that has several sections: analysis systems, component systems, custom systems, design exploration, and act. So in our case, we're going through the analysis system. And if you click on the analysis system, you can see several multiple things to perform. For example, fluid flow, design assessment. In our case, we're going to perform a static structures. So whether you double click on it or you drag it to the white page here, after that you can see the small pop-up window that appears to you. It's important here to follow these numbers in order. So the first thing was to choose the analysis systems, and it's agreed to be a static structure. The second one is engineering data. If you click on it, the engineering data, it's simply anything related to the material. So you can choose any material you want. The first table here, you can choose the data source you want. For example, you have general material, composite material. If you click on the general material, for instance, you can see in the second table here the outline of the general materials. So you can see structural steel, stainless steel, silicone, and many other materials. So you can simply choose, click on any material you want to add it for your design, and then for the last table you see the properties of the chosen materials. For example, density, tensile strength. Also, you can change or play with the values of the properties of that materials. This is regarding the engineering data. The third point here is the geometry. In this case, you have two choices: whether to generate your own model within ANSYS software. It's allow you to model and create your own, or you import it from any other software. For example, you can import it from an existing file of SolidWorks, and I prefer to take it from SolidWorks since it's much easier, more easier than ANSYS modeling, and more efficient as well. So you just right click on the geometry, and then you go with import geometry. You browse it if you have that file. In my case, it appears here, and it's a triangle model. So you see, click right here, the right click here beside the geometry, and then you go to the fourth point, which is model. If you click on the model, you wait just for a few seconds until a mechanical page of ANSYS software would appear. As you can see from the bottom side here, it is still processing to start the mechanical page. So we wait a few seconds. There we go. This is the mechanical page of mechanical window of this ANSYS software. Wait until the process complete. Okay, this is our model. I have created a simple model on SolidWorks, which is a triangle with a circle extruded cut throughout. This is, if you look out on the left side here, outline, you can see the project and the model. We have identified our model and the geometry as well, and materials. In our case, we haven't picked up a material, a specific material. So it's gonna be the default and the typical material by ANSYS, which is going to be structural steel. And this is the coordinate system. And now we go to the one of the important factors to consider here is the mesh. So if you want to generate a mesh, then right click on the mesh, and then you go to generate mesh. So you can see here the mesh is already generated. If you want to change the sizing of that mesh, then simply what you need to do is right click on that mesh, and then you go to insert, and then you go to sizing. If you click on the sizing, you can see here on the bottom left here the detail of sizing. You just need to click on the geometry you need to size it. You can choose one surface or multiple surface just by holding on control key and choose multiple surfaces, and then here you can type the element size. For example, let's go with the geometry here, and we choose this as our geometry, and then element size, we can identify the element size, and then we go with that number. So in our case, we're gonna stick. I'm gonna stick with the default sizing by ANSYS. So we're not going to change the sizing. So I'm gonna delete it right now and stick with the sizing that's being generated by the software. So this is regarding the mesh and the sizing. Now we go to a static structure. So several things here you can perform. You can add loads, and you can add support, fixed support. I'm gonna add some load on my structure here, but before that I'm gonna define a fixed support. So you right click on the static structure and then insert, and you go to fixed support. Then you click on the surface you wanted to be a fixed support. In my case, I'm gonna choose the bottom surface of the triangle here to be the fixed support. So you click on that surface, then you go for apply. You can see here the bottom surface has been identified as the fixed support of the model. So this is regarding the support. Then you go again, and if you want to insert a load here, you can see pressure, hydrostatic pressure, force, remote. I'm gonna go with the force just to make it simple, and I will choose a surface to have the force applied on. So I'm gonna choose this surface. Cool. This surface, I'll choose it as the surface that I'm gonna apply the force on it. And you need to identify the magnitude here. Let's go with, for example, 300 Newton. Then you identify the geometry, which is this. Then you define the direction just by clicking on the click here, define. If you want it inward or outward, I'll go with outward. So let's keep it outward, and on that surface, and of magnitude of 300. So this is the selection of that surface, and there we go. We have our forces that has been identified on that surface outward of a magnitude 300 Newton. This is regarding the force. Now we go to the last step here, the solution, where we can simulate and add the stress analysis as well as deformation and many other things here. So let's go and right click on that solution, and then we insert deformation. I'll go with the total deformation of that shape, and then I will also insert a stress, an equivalent stress, and it's gonna be the von Mises. So now I have added a deformation, total deformation, as well as an equivalent stress analysis of my shape. So it's almost that's it, I believe. Just we need to click on solve here, and we wait till the processing is complete. The bottom left here is 78. After that, we can see the result here. Let's go for the total deformation. As you can see here, this is the total deformation. This is the minimum and this is the maximum, and the auto scale is 1.4, and you can change the scale you want to. So it is auto scale. I'll keep it as it is. And you can see here maximum and minimum. The maximum here is just to give you and to tell you where is the location of the maximum. In our case, it's gonna be here, somewhere here, the maximum stress. Sorry, in this case, it's gonna be the maximum deformation. And if you click on minimum, it would show you where is the minimum, and it's gonna be 0 here. And if you notice, it is on the bottom side, the bottom surface of our model, because we have identified as a fixed support. And you can also probe any location you want to know the stress on it. You just need to right click on the probe, go back to result and probe, and then you choose any location you want. For example, let's see, it's 4 point something. This is regarding the deformation. You can also animate that, perform animation. So you just need to click on that bottom. You can see the animation of our model before loading until load has been applied. This is regarding this total deformation. It is almost the same with the equivalent stress. You can see the minimum here and the maximum over there. You can click on the maximum here to see where is the maximum location. Minimum, you see where is the minimum. So this is it, I believe. And then you can also probe. Just click on the probe and choose any location you want to see the stress on it. This is the animation of the stress, you can see here. Before applying and after applying the load. That's it. Thank you so much, guys, for listening, and I hope you enjoy that video and get benefited from it. Thank you so much.